Students, I'm going to go ahead and go over the combined gas law and how to solve problems involving changing pressures, changing volumes, and changing temperatures. So first off, all of our gas law equations can be found on the back of the periodic table. So if you flip your periodic tables over, on the left-hand side, there's going to be a section that has all of your gas law formulas. Now here's what's very, very important. Up here in black, it says temperature has to be in Kelvin. Regardless of which equation you're using, you have to have your temperature in Kelvin. Now with these ones that we call the combined gas laws, where you're having changing pressures and changing volumes, the pressure and volume unit can be in any unit as long as the unit is the same on both sides. But the temperature has to be in Kelvin. Even if you have to solve for Celsius at the end, you have to convert a given Celsius temperature into Kelvin to do the calculation, and then you convert it back into Celsius after the calculation has been performed. Okay, so what you're going to want to do is figure out which variables the question is dealing with so you can pick out the right equation to use. So taking a look at this example here, so I'm trying to get my annotate tools. All right, it says a gas is collected in a 242 milliliter container, so that's a volume. The pressure of the gas in the container is measured and determined to be 87.6 kPa. That's a pressure. What is the volume? So we're looking for another volume of this gas at 101.3. That's our second pressure, kPa. So since we're just dealing with volume and pressure, you're going to look on your equations on the back of your periodic table and find the one that just has volume and pressure. And that one is P1V1 equals P2V2. So then you can plug in the equations here. So we've got our pressure one is 87.6 kPa. Now I'm going to leave these in kPa because we have kPa on both sides. Our V1 is 242 milliliters. Our P2 is 101.3 kPa. And we're solving for V2, that's our X. In order to get V2 by itself, we're going to have to divide both sides by 101.3 kPa. That will get us V2 by itself. So we have 87.6 times 242 divided by 101.3. When we're multiplying and dividing, our sig figs are going to be based off of whichever one has the fewest amount of sig figs. So we'll have 3 sig figs for our answer. And our answer would be 209 milliliters. And it's milliliters because we're looking for volume, and the volume over here on the left side was in milliliters. Okay, so let's take a look at this next question. A sample of gas at 15 degrees Celsius, so that's a temperature. Oops. Oopsie. Let me get my drawing tools out here. That's a temperature, temperature 1, and 1 atmosphere. Atmosphere is a pressure and has a volume of 2.58 liters. What volume, so we're looking for volume again, that's another volume, will this gas occupy at this temperature and 1 atmosphere of pressure? Now what I notice is that my pressures are the same and my pressure doesn't change. So I don't even have to worry about the pressure there. I'm just going to be worried about the volume and the temperature. So I look on the back of my periodic table to find the equation that has to do with volume and temperature. And it looks like this: V1 over T1 equals V2 over T2. So I'm going to go ahead and plug it in. But first, remember, I said when I was showing you the equations that temperature always has to be in Kelvin. So we have to add 273 to this. That's going to get me 288. And we have to add 273 to this. I think that's going to be 311, but I am going to double check because I don't trust my mental math right now. 311. Okay. So my first volume is 2.58 liters. And my temperature 1 is 288 Kelvin. And that's going to equal my V2, that's going to be my X, over 311 Kelvin. Now, when you're doing equation and solving for these, the easiest thing to do is cross multiplication. So you're going to multiply the diagonal that doesn't have your unknown. So you're going to multiply these. So you have 2.58 times 311. Then you're going to divide by this here, the variable that has, or the diagonal that has the variable. So divided by 288 is going to equal your V2. So we'll have 2.58 times 311 divided by 288. Again, multiplying and dividing our sig figs are based off of whichever one has the fewest amount of sig figs. So we're going to have 3 sig figs for our answer. So my answer would be 2.79 liters. In liters because my volume for V1 was in liters. Okay, so looking at this next question here, a 2-liter flask, so that's volume, contains helium gas at a pressure of 685 torr and a temperature of 0 degrees Celsius. What would be the pressure in a flask if the temperature is increased? So we're looking for pressure 2. If the temperature is increased to 150 degrees Celsius. So first off, there's not a V2. Well, that's because the flask isn't changing. The size of the flask is not going to change. So we don't have to worry about this volume here. So we're only concerned with pressure and temperature. So again, look at the back of your periodic table and find the equation that has only pressure and temperature. And that's going to look like this. P1 over T1 equals P2 over T2. So we have 685 torr. Now remember, we're going to add 273. I'm recording. Hey, sorry. I have to add 273 to this. Sorry about that, everybody. So this is going to be over 273 Kelvin. And I'm looking for P2, so that's going to be my X. And I have to add 273 to this one. So 150 plus 273 is 423 Kelvin. So again, I'm going to cross multiply. So that means the diagonal that doesn't have the variable, so this diagonal, I'm going to multiply 685 times 423 divided by, and then you divide by the diagonal, excuse me, that has your variable. So divided by 273 is going to equal my P2. So 685 times 423 divided by 273. So P2, I'm going to have 3 sig figs again on this one. So even though the calculator says 1061.373, my answer is going to be 1060. And my pressure units were torr in this case, so I still have torr for my pressure units for P2. All right, next question. We've got a helium-filled balloon has a volume of, so this is our V1, 3.40 liters, and a temperature of 25 degrees Celsius and 120 kPa. kPa is a unit of pressure. What is its volume at STP, assuming the number of particles is constant? Now, don't forget, if you see STP, that's giving us valuable information. That's telling us that we're at 0 degrees Celsius and 1 atmosphere of pressure. Now, because I'm lazy and I see that my units of pressure over here are kPa, I don't want to do an extra pressure conversion. So I'm going to just change this to the standard pressure in kPa, which is 101.3. I have to add 273 to this, so I know that this is going to be 273 Kelvin. I want to make sure I add 273 to this temperature as well. So that's going to be 298 Kelvin. So I've got pressure, temperature, and volume. So look at the back of your periodic table, find the formula that has pressure, volume, and temperature. So I've got P1 V1 over T1 equals P2, V2 over T2. So I've got my pressure 1 is 120.0 kPa. My volume 1 is 3.40 liters. And my temperature 1 is 298 K. My pressure 2 is my standard pressure in kPa times my V2 over my T2, which is 273 Kelvin. So just like last time, I'm still going to cross multiply. It's just that this time I have a little bit more numbers. So I'm going to take this diagonal. I'm going to multiply those numbers together. So I have 120 times 3.4 times 273, and I divide it by my diagonal where I have the variable. So 298 times 101.3. So when I do all of that, 120 times 3.4 times 273 divided by 298 and 101.3. Make sure you do this in the calculator to make sure you're getting the same answers as me, because this is the one where students always make a mistake just inputting it into the calculator. I should get 3 sig figs, so I should record my answer as 3.69. And because my units of volume were liters for V1, my units are still liters for V2 over here. All right, so next question here. A gas has a temperature of, so that's T1, and a volume of, if the temperature is raised, T2, and the pressure is not changed, what is the new volume? So again, look at your periodic table, the backside, to pick out the right formula to use. I've just got volume and temperature again. So that means I've just got V1 over T1 equals V2 over T2. So my V1 is 4.5 liters. Make sure that you add 273 to your temperature. So I have 284 Kelvin. Nope, 287. Mental math. 287 Kelvin. And that is going to equal my V2 and my T2, which is 302. So I've got to remember, multiply by the diagonal where I have no variables, well, no unknown variables, I should say. So 4.5 times 302. I'm going to divide it by my variable, or my diagonal, I keep saying that wrong, where I have my unknown, so that's 287. And that's going to get 4.5 times 302 divided by 287. 4.7, because I only get 2 sig figs, and that's going to be liters because my unit of volume is liters over here on the V1 side. So that's how you do anything involving the combined gas law, where you have changing volumes, pressures, and temperatures. So if there's any questions, just let me know. All right, thanks.